What happened? Oh, the stand? Did it fall or who? Ah, did you just have to hold it? Oh, really? You start with some of your slides. You have to add some stuff. Yeah. And then, you know how much it will take?
Here actually we have 20 minutes to spare.
Okay.
So I'm doing some time check in between and say putting that okay, it can't go beyond 420.
This is what
that should be its presentation.
that should be your.
So that Taylor should finish by 420. The MLE draft I have no idea. I haven't read or followed, so I will.
Yeah.
I think you have probably more. So we need a microphone here. No, for the presenter. For the presenter.
You want to stand up at the camera.
Hello everyone, can you hear me? Well, welcome to the second session of 6LO Working Group. Gabriel Montenegro and I'm Samita Chakrabarti. So we right now today we have a shortage of microphone here. Just to let you know, if you are presenting, we might ask for the microphone if you don't get additional one. So this is the Note Well page. And we have a full agenda today, about 9 or 10 presentations. We will start with some news from the chair slides based on the ITUT discussion last session. And then this is our agenda. If you have any comments on the agenda, let us know now. Okay, so we have, and then I would like to share, both Gabriel and I like to share our status on the ITUT dispatch byte allocation based on the liaison text that we received from ITUT SG15. So we are working with a role working group, Ralph Drums, who is our technical advisor, and Scott Mansfield to craft the liaison text response, which is due tomorrow. And the essence of the message is that the IETF will not change whatever definitions we have for the dispatch byte allocation in 4944 and 6282. And we will collaborate with them for the bytes they have used already for their G9903 and 9905 specification. Although we will also mention through our liaison text that in the future they will coordinate with us for such allocation they make in their standards documents. And so for going forward, we discussed with among ourselves in the 6LO office and Brian, but we would also like to discuss it with the working group that we are now going to leave the current escape byte with the current IANA allocation, and then we will register the bits that IANA that ITUT SG15 has already defined, and then we will use another, the working group will work to define other escape bytes. So Gabriel, if you want to add and maybe take some if the working group is interested in actually defining a new escape bytes.
Yeah, so as this is sort of a consequence of what we're responding, so the consequence is that we're not going to touch the current escape bytes. The question to the working group is then to accommodate other uses, like, for example, the next presentation we'll see, and potentially others. We might still need some other form of extensibility. So in that case, how many people here think that we should use one of the yet unassigned codes to define a new, let's call it escape or whatever, we can come up with a second name, but for now let's call it escape 2. And of course we will add some structure there, think a little bit more thinking behind that. But for now, just the initial, should we proceed and define a new one in which we will actually provide some extensibility? Is that a clarifying question, Carson?
No, was just going to say it's a wrong approach.
Say what, excuse me?
Wrong approach.
Okay, could you say what the suggested approach is?
Well, we have a registry. That registry has plenty of open space. We should be frugal in assigning that space, but we should only assign it when we need it. And creating a structure that we don't know how to use sounds like pretty much the same mistake we made in 2007.
But I thought you were co-author of one such proposal.
Yeah, but it's not an escape byte or extension byte.
What do you want to call it?
One additional mechanism that actually is specified out.
That sounds fine. When I said escape, I said, I don't know what we call it now. I'm calling it escape 2. What do you want to call it?
So
extension mechanism.
The point is, we are not doing this to give away space. We are doing this to solve a problem.
Right.
And then,
yes, for example, like the next presentation, which you're co-author of.
Yeah, I'm just saying.
So for that, for which you're a co-author of.
Talking about what's the best way to give away that space, but we should talk about what problems do we have and how much space do we want to allocate to solving that problem.
So you don't want to take a hum?
I think it's, as it's phrased, it's
let's put it this way. If I were to hum right now, maybe some people would hum against it. You would be one of them. Would that be okay? So that we can see if it makes sense to continue with this or not? Might be an overwhelming negative.
Yeah, so of course I don't have a problem at all with using the space for something useful.
Right.
So I cannot possibly hum into one or the other direction because it's not clear to me what.
I'm confused because you're proposing one such use.
Yesterday I was in a working group where people said it's so confusing that there's even confusing about which parts are confusing. And I think we are exactly at this stage now.
Why don't we then postpone this until after Pascal's presentation, in which this might be clear. So, point taken. Okay, let's not do it now.
Okay, so Pascal, next. Pascal, you are next.
So I don't have many slides for today because the core of the compression mechanism that we're proposing is not the hot topic of the day. We've been asked by Roll and Sixtish to design a compression mechanism for the ripple extensions in the IPv6 packets. And so there was a question how and where we do that compression. And we ended up with a TLV-based mechanism that is extensible for many other applications. And for that TLV application, which is a real-world application, we actually found that we needed some space, like 25% of 1 octet, basically, in terms of bits. And the questions we try to solve, which doesn't really have a solution, is where can we fit this TLV extension we're talking about within the dispatch? And that created all sorts of discussions across the mailing list, across the groups, and even between standard bodies now, leading to this G9903 discussion that we get today. So in the draft, the 6LO-RH as it stands, we've got 3 proposals. Can we go next slide, please? Oh, by the way, can you come back a second? Sorry. I colored in colors things that cannot be extended. So basically, not a LOPAN is not something we own at all, so we cannot touch that. The mesh shader is not extensible at all. The way it's designed, you have to use it exactly as it is. There is no way to do anything as an extension to that. So we have some free space today in where HC1 is defined, and we have a bit of free space that you don't fully see on the right, because where the fragments are defined is effectively fragmented, which is kind of fun. Yes, if you look at it. But basically, we had this trouble of finding place where we would put the 6LO-RH. Next slide, please. So in the current draft, we have basically 3 proposals. The first one, as spelled, is clearly not acceptable. It's just reuse the mesh space the way it is defined. Actually, the wording that Jonathan proposes to us is to say, oh, actually, on theory, we place it somewhere else, but then we over-compress stuff. So it's a second layer of compression, which runs after 6LOPAN, which remaps multiple bytes of 6LOPAN into a single byte, which would end up keeping some things in the same place, but putting some other thing in the same place because they are mutually exclusive. And because the 6LO-RH is mutually exclusive with the mesh header, because one is route over, the other one is mesh under, we could effectively, in the frame in the air, place them at the same place, but it would be not another writing of a standard. It would be an extra compression of 6LOPAN, the routing header being logically placed somewhere else, but super compressed to end up in the same place. It's one way of seeing it. So the second proposal is basically what Gabriel was talking about. So what the second proposal tells us is the 4944 defines mechanisms which really talk about, apart from the IP packet itself, talk about things which are at the very beginning of the packet. You can have fragmentation, you can have mesh headers. These things are at the very beginning of the packet. Even NALP, it's really first 00, which tells us that the packet is not 6LOPAN. You expect that as the very first octet of the packet. So once the fragment, the mesh header, the NALP are passed, there is a point where 4944, apart from the IP piece, cease to be of importance. It's done, right? So after that piece, if we could delineate it, we could say, oh, now we can reuse that space to index something else. And that's really what Gabriel was talking about, and that's really what we are talking about with proposal 2. It's option 2. We really say, oh, we define one value of this dispatch bit, maybe all ones, and we say, once you see this all ones delimiter, you can say, oh, from there, the dispatch is redefined to a new set of values. So we reopen all this space for new definition. And we are using effectively a fourth of that space for the 6LO-RH. And then the third proposal in the draft shows how bad it is if we don't do that, and if we really try to fit everything we need inside the free space that you saw on the right with the fragment. And it's more like a demonstration by the absurd that we should not be doing it. And that's basically what I have for you today. I don't want to go into the mechanism, and we don't have so much time, but I just wanted to get a sense of the room, basically the same sense that Gabriel wanted to take as well. Whether this option of saying, okay, from this separator, and maybe you don't call it escape because escape is so much overloaded, but from this separator, 4944 is done, we can reuse that space to indicate something new. And because this delimiter is very clear, it's new, it clearly separates the first use of the dispatch with the second use of the dispatch, and we reopen most of the dispatch space. Is it something that would be acceptable? If that's the case, now we have a specification we can run upon to do the TLV thing, and it has a real world use, and we can show why we use the TLV the way it's done, because in the same draft we show how it's used and why it's defined this way. Okay, and that's when really the ham
One more clarifying piece of information there is that this would be, like Pascal said, this would be a new value. So legacy devices would not know what to do with it, just like they wouldn't know what to do with Escape. And the only thing that rests for us is clarify what we expect those legacy devices to do. And the only thing we can expect is the worst case. They haven't seen this. So the only thing we can expect, they're going to drop the entire packet. So since it's such a catastrophic thing, anybody who survives after that is probably likely to have been updated and know about this and know the structure. They may not know the specific extension, but that's where we're going to have a TLV so that if they don't know that particular one, they can skip over it. We'll have rules, and we'll discuss this at length, of course, about how to do that. But the idea is for legacy devices, it's a non-issue because whatever they see that they don't know, they're going to choke, basically.
Yes, and I must say that the draft now is very clear about the capability to skip a not understood type, right? So there is the same thing as we have in the option headers, like there is this bit which tells you if you don't know this type, then you can skip it, in which case that's why it's an LTV instead of a TLV. The length comes first, so you know what to skip if you don't understand the type. Okay, so for everything which is skippable, that can be ignored, there is always a length that you can skip. That's part of the design of this TLV.
Yeah, Carsten Bormann. I would like to phrase this a little bit different. Essentially, what we have here is a trade-off between how short we can make the bits for the problem we're trying to solve, which are 6553, 6554 right now.
And extensible.
And extensible, but at the moment, we're focusing on solving the 6553, 6554 mechanism. And the trade-offs between how short can we make that and how much of our treasure chest of dispatch bytes do we spend for that. And of course, the alternative is not 1 or 32 or something like that, but we could also spend 5 if there is a good reason. Now, these are a little bit complicated equations in the end, so spending 5 probably doesn't make any sense at all. There are probably only a few situations that make sense. But spending 1 octet essentially, 1 dispatch byte value essentially says, oh, this 6553, 6554 stuff really isn't that expensive, it really isn't that important, and so it's completely okay to spend another octet there and so on. On the other hand, if we think a lot of packets in the future will have these headers, then we may want to spend more there. I don't have an opinion on that. The only thing I want is that we make this decision in a very conscious way, and don't let us lead by some terms that sound good, like another escape or something. It's really a very basic question. How much of our treasure chest do we spend? Now, the interesting thing about this treasure chest is that the TLV scheme that you are proposing is actually not consuming all the space that we are consuming for this. So other schemes that would benefit from prepending headers to 6LO packets could then go on and use that as well, not using up any dispatch bytes they would have been using otherwise. So we are spending a little bit money, but a little bit of that money actually is investment. What's the best way to undermine? Okay. So part of what we are spending actually is an investment. And again, we have to think, how many other cases are we going to have that need these prepended headers? In 2007, we only thought about the mesh header and allocated a quarter of the space for that, which was wrong. But it has happened, so we don't want to change it, apparently. But right now, we are building something that is very extensible. So of any percentage that we're actually spending, only a certain sub-percentage goes to 6553, 6554, and the rest is available for other things.
Yeah.
Assuming, of course, that we have, we'll have these other things in the future. So if we never do another forwarding mechanism that needs to prepend headers, then we have misspent that money.
I can give you examples which will come very soon, right? Basically, IPHC is what it is. It's IP. And everything ICMP, for instance, I'm thinking about the REPL, for instance, right? We'll need a compression mechanism. So soon as we are done with this, we'll come up with how do you compress REPL itself, not just the packets, but the control protocol, because REPL needs compression. So, and it will fit right there. So that's another example that will need this 6LoRH thing. But
we already can do that.
Compress REPL?
Yes.
It's not specified.
It is. It's RFC 7400.
6LO for REPL? Okay, I will look it up.
Oh, yeah. Yeah. Generic.
You can use 7400 to compress everything.
Oh, everything. Oh, yes, that's your compression mechanism. I'm talking about a 6LO pen for REPL. Now, yes, you have the general purpose compression. Okay, I understand now. Yeah.
Okay. So I don't think we want to design the actual bits and bytes.
There is extension coming up.
What should we call it? I think escape is not what people want to hear, but an extensibility mechanism. Does that sound like a reasonable thing to say? So if people feel comfortable, they think that we should go forward and define. Clarifying question, Robert?
Yeah, Robert Craigie. So I was calling this a switch in the mailing list because that's effectively what you're doing. You're switching to a new dispatch space.
Yeah, the term context switch is what Brian was using actually. Yeah. So I kind of like that.
Me too.
So, okay. So you think it's highly misleading? Let's not worry about the name. We're going to call it context switch extensibility now, escape. And then we'll figure out what to call it. So if you think the working group should go forward and define such a context switch extensibility name to be inserted here mechanism, please hum now. Okay. Now, if you think we should not do that, people who are not at a mic, please hum now. That's pretty clear. We'll confirm on the mailing list, but that's pretty clear. Whoever's taking notes, please do note that.
Quick clarifying question: what would be the way forward? Because I asked that on the mailing list, but too late. Do you want one RFC to just define the byte, then one RFC for the TLV, then RFCs for the content? I mean, how well we can ask a question now we're here, right? How do you want
we can do that hum as well. So the question is, should we have one RFC that only defines the mechanism of the framework, or should we have that first example? Maybe we have another one, but at least one example. Of which, the REPL justification is it. Should we have that as well grandfathered in and, being the first one to be IANA registered?
Let's write those documents first and then see whether they should be split or combined and so on.
I'm sorry, couldn't hear what?
Let's write those documents. Because
let's not define now.
Let's live on their own or they can be combined.
Why don't we just start developing the document or documents and then we'll figure out later on if we want to. Yeah, that makes sense.
Brian Haberman, why don't you just define that value in the IANA registry document that you're talking about?
I would like to have some rules. Once that gets defined, we should immediately have some rules as to how to deal with it, how to skip it. The part about skipping it, I think, is really important to be there the first time it appears in IANA. Otherwise, we might have another synchronization problem with people who understand it but didn't know how to skip it, and then we can't do the TLV.
And you should be able to point on which RFC this code is being used. So kind of putting it in 6LoRH and said self is good, right in the right column. Which spec does it correspond to? Well, that would be the 6LoRH itself.
Yeah, Robert Craigie. So I think it'd be a good idea to have a separate document to define the usage of this switch or whatever we're going to call it. And then, bring in the concept of these pages, dispatch pages. So we have pages of dispatch values now.
Pages is good too.
Yeah. So at the moment we're considering having one page which has your 6LO stuff in, and then
just using a fourth of the page.
Exactly. Yeah.
And then it's extensible.
Exactly. So and then there's the rest of that page, and then you could have a different page later on, whatever, with a different byte. We still have quite a few bytes left in the original 6LoPan dispatch page.
Okay. So it sounds like that we are going to go forward with the current draft INR registry document and register the INR bits with the existing escape bits. That's number one. That's old. And the second one, I believe the working group would intend to work on this, and then we will have some quorum and discussion around it, and then we will have at least one document or maybe multiple or two documents. I think one might be better, so we can have the guidelines and requirements, and then the solution, the formats.
Right. So I can basically clean up 6LO-RH to remove option 2 and option 0, and keep this one, and then clarify what it becomes. And propose a value like Fox, and then we'll discuss over that.
There are other options other than 6LO-RH in the future, so we have to keep that in mind as well.
6LO-RH is only using the 1/4 of the new page, as Robert calls it.
1/4, that's a lot.
2 bits. That's what the mesh header is in the first one. We are using.
Okay, so we have to come to that agreement.
It opens you for the world.
Maybe later.
We'll figure out the exact details later on, but so we have a general direction at least.
Thank you. So next is Yongjin, NFC.
Hi, everyone. Okay, this is IPv6 of NFC. Next page, please. NFC means near field communication. So nowadays, the NFC technology is widely used in your smartphone, iPhone, or Android series phone. So in NFC there are 3 modes: peer-to-peer mode, and read-write mode, and NFC card emulation mode. So until now, only NFC card emulation mode is widely used for the payment. But we are targeting on the peer-to-peer mode to transfer IPv6 packet of NFC. Okay, next page, please. So in the last March, this document was adapted as a working group document. So in this meeting, we revised as a 0.1 version. So in this version, the update part is 3. We explain. Next page, please. Okay, the first one is the NFC MAC PDU and the MTU size of NFC. So in NFC specification, the UI means the a numbered information PDU. In this version, we add this format. This format is used as the connection risk cases. And the other thing is MTU. In NFC, the MIU, maximum information unit, is used. It is the same as MTU. So in MIU, it is calculated by 128 bytes plus MIUX. MIUX means maximum information unit extension. So it's value from 0 to 247 bytes. So the total MTU is 128 bytes to 2,176 bytes. So as you can imagine, the IPv6 packet can be inserted in one NFC frame. So FAR in NFC is not required, as we talk later. Next page, please. And it is the state list address auto configuration. So in this version, we describe as the general modify EUI 64 format to make consistent other IPv6 of few document. So IPv6 link local addresses is configured like this. Next page, please. Okay, this is FAR, implementation and assembly. So as I said, that NFC itself provides payload from 128 bytes to 2,176 bytes. So the NFC functionality, as defined RFC 4944, is not required in NFC technology. But we recommend that the default configuration of MIUX value is 0x480 to fit in the MTU of IPv6 packet. Next page, please. Okay, so in the next meeting, we will update the header compression part. And the current implementation is that we are the verification on header compression and packet implementation. Also, we are targeting on the simplification and enhancement for NFC network device driver. Because, you know, nowadays the commercial NFC module doesn't have generic network device driver. It only supports general I/O port. So now we are converting for the generic NFC network driver. So in the next meeting in Yokohama, we hope to demonstrate in the ETSI, the 6LO plug test. That's all. Thank you.
Any questions?
Just a moment again. We have discussed this before, but just to be redundantly clear, because this issue comes up again and again. This uses interface identifiers, MAC addresses in the interface identifier, actually SAP addresses in the interface identifier. And this is one case where we believe that this doesn't lead to any trackable identifiers being exported to the outside. And I think that needs some text, just as we are having the same discussion with the 6LO back right now, where the situation I think is very similar. We need to come up with text that explains why this is not a privacy problem.
That's a very good point. I think every single document going forward will have to think about that, and Dave's presentation will talk about that.
Oh, good.
Okay, I thank you for your comment, and I give you one response. In NFC case, the SSIP can be changed as a single touch. So for privacy issue and the tracking issue, the NFC doesn't have it, but we will consider it also for your comment. Thank you.
Gabriel Montenegro. So I have a couple of questions. One is, you mentioned different modes, and in particular, peer-to-peer mode is the one that is used for these.
Yeah.
So NFC is in all smartphones. Do all of those modes, are they all implemented in all smartphones? Or?
Actually, our implementation is not using smartphone directly. We are the USB, the NFC dongle mode. So some commercial NFC dongle, NFC model support P2P mode, but some commercial mode do not support. So it depends on the manufacturer and their product. So nowadays, not all NFC do not support the P2P mode, because the NFC technology until now it is used for the payment.
Yeah. So the third mode, the smart card mode. Yeah.
Yeah.
And the other one is, have you heard back? I know I asked you recently, but have you heard back from the NFC forum?
Yes. No. So I remembered in the last meeting, you asked the comment, you give comment. So I contact the NFC executive director, Paula Hunter, but unfortunately there is no response. I'll continually contact their collaboration and correlation with the NFC forum. Okay. Thanks.
Eric Ving. Most probably, maybe a naive question because I don't know NFC enough, but NFC for me, that's only a 2-node network.
Yeah.
So why do you need a 64-bit interface ID in this case? Because the /127 should be enough.
Thank you for your comment. So so if my memory is correct, the same issue is done in the 6LO main list. So right now, for make some consistency of IP bricks of few document, for example, BLE and MSTP and the rollback. So we follow the generic, the IPv6 address computation. So we made the EUI64 the format. So so that's the, I believe that this is our policy or the rule. How can I say it, rule? So that's the reason. I know that there are many pros and cons because the NFC used the 6-bit SSAP, so we can utilize other remaining parts. So we will continually discuss how to is the best way to handle that issue.
Okay,
so until now, we follow the general, the 6LO policy.
Thank you.
Thank you.
So next is DECT-ULE, Dominic.
Good afternoon. I'm Dominic Barton, and I'm going to present this draft about IPv6 over DECT-ULE. I deliberately put company logos. I put company logos on the first slide, although IETF doesn't like company logos, just to show that this is real stuff commercial companies are interested in, not research idea. Yeah, we might even maybe run IPv6 over DECT-ULE. So, this, which button?
It's not working.
Should I point to this one?
Maybe it's not working from that.
So just a recap on DECT-ULE. It's DECT is an ETSI standard. It was originally designed for cordless phone. It's been around for over 20 years now. More recently, the extension for low energy data transmission has been put out, and that's the -ULE that you see next to DECT. I won't go into the radio details and all the L2 stuff. It has already been presented about 2 years ago by Zach. I just want to point out that DECT has a dedicated spectrum on the 1.9 gigahertz range, and so nowadays with the interference and explosion of connected devices, this is a good selling point for DECT, that you don't get that much interference, or at least the devices you get interference from speak the same protocol. And also it's a rather long range compared to the original 15.4-2003. So are these the new slides? No. Yeah, okay, so anyway.
I can do the switch for you. I can.
No. I sent you in your slides, but anyway. This is the original version of Friday. Never mind. So just a few, some news about DECT-ULE. ETSI is actively working on that. So 6LoWPAN has got a protocol number for DECT-ULE. So now it's a legal protocol to transport over DECT-ULE. And also in an effort to have this initiative move forward, the ULA Alliance has contracted development for an open source 6LO stack, so, which will be available fall this year. And so anybody will be able to find source code for this, for 6LO or DECT-ULE. And also, the 6LO working group and ETSI are considering DECT-ULE as part of the interop. That was already mentioned during the meeting on Monday. Coming to the draft. So this document has copy and pasted much text from BTLE. So thank you, the BTLE authors. So it was not just a convenience for us for writing the document, but it's also a convenience for you to read the document, because we even replicated the structure, the paragraph numbers, and everything. So if you liked BTLE, you will love Dectually. You can probably even do a diff on the text source, and that help your reading. You'll see only the few words that have been changed between the two. So basically, it's pretty much the same. We use Dectually in the star topology, even though Dectually allows to do a few other things like roaming between base stations, but we don't consider that in scope for our document. We also have a limited payload. It's 38 bytes in case of Dectually, but doesn't differ much from BTLE. Dectually also specifies its own fragmentation and reassembly mechanism, so we don't have to use that from 4944. And probably one difference between our proposal and BTLE's proposal is that we only intend to register one interface ID per prefix, making things even simpler. The document was adopted by the working group last year. Comments were received. Thank you, Ralph and Gabriel, who provided comments on the document. We made the update, so we believe right now we're up to date with all the comments. I'm probably not going to go through the changes that we made in the various revisions, except to say that we clarified some text. We changed a few shoulds and musts. And also we actively followed the conversation about the privacy issues. And so we referred to the 6-man default IDs and the original RFCs that this document points to, like cryptographically generated IDs, etc. I think that's it. Oh, yeah, we also explain how we can derive IIDs from the various layer 2 IDs that Dectually provides. There are several of them. One is dynamically allocated by the base station when a handset or device registers with the base station, and this is probably the base mechanism by which you can avoid trackability by generating a new IID every time you register to your new base station. Okay, as conclusions, we have real stuff out there. The new slides I was hoping to present had the pictures of actual devices that you can buy today for Dectually. And those guys, those companies that you saw logos of in the front page, they are really eager to get a standard so they can produce standard compliant hardware or equipment. So we have vendors that are ready to move forward. We will have an open source implementation for anybody to get and catch up with the early guys. We think the document is ready. We'll be following BTLE for the privacy discuss that I already mentioned. And I think then we'll be ready for last call and moving forward.
Okay.
Questions?
So, does anyone have any objection for this document to go for working group last call?
Customer, no, but my comment will be, has this been through an interop?
Mm-hmm.
Yeah, not yet, but they are planning the interop next time.
I think we really should have a working group call, whether the first or the second, I don't care, after the interop, because some things will come up there and we shouldn't try to finish the document before the interop happens. But if it helps for the interop to indicate this document is done, we might as well have a first working group last call now. But
right.
It cannot be the objective to then ship it. We should have the interop first.
Okay. While that is true, we have some other documents we have passed through this working group without having any interop testing, because this is going to be our first interop testing. So we Yeah, if there is no objection, we will. We will have Shepherd's review, and then we will go forward with last call, and then if we come up with other things, then we'll.
Yeah, as a personal opinion, Carsten, I agree with you that I'd feel better to have this become an RFC after we've done interop. On the other hand, we are trying to get manufacturers, equipment vendors come into the interop, and so we would love to be able to tell them that this is stable. So we'll try to find the best trade-off between the two objectives.
Pascal Thubert, two things. I agree. We actually found the minimal draft at 6 stage. We passed last call before the interop, but we still found stuff. So it was like we held the document from ISG review till the interop was passed, and we found a few things. I think you always find a few things. The other point is, anyway, if you take so much from BTLE and there is this ISG review of BTLE, then probably you want to do another copy-paste pass after the ISG is done with it.
Right.
So.
Point taken here.
Yeah, but just a very simple question. What type of MAC addresses do you use in DACULE? 48-bit?
There are a number of layer 2 addresses. Some of them are 40 bits. Another one is 20 and 22, if I believe right. So we extend those to become IIDs if we decide to use layer 2 identifiers for IIDs. Or we can just use if devices have an IEEE 48-bit identifier associated to them, we can also use that one. Or we can use the ones that dynamically allocated from the base station. So lots of options. And we don't mandate any of these. We allow any of those to be used with the recommendation of concerning privacy.
Thank you.
Okay, so Dave Taylor, and as author of one or two of the privacy-related documents in 6man and so on, my goal here is to tell you what sorts of things you should put into the security considerations section of documents. And yeah, sometimes people put it into, say, the stateless address auto configuration section, as long as it's in there. I know the DECULE guys put some stuff that's in there. My goal here is to tell you what should be covered into there. Not necessarily to tell you exactly what the answer is, but to help you understand what the considerations are and maybe some ideas of things that you could put in there, okay? So, and I'm not really talking about solutions like I talked about last time. It's actually covered by the same draft, but it's completely different sections of the same draft. So I'm only talking now about what you should put in security considerations or somewhere in your document when you're doing an IPv6 over some type of link document. Okay, so in the privacy considerations document that's going through the IESG now, there's 4 main threats that are covered there, okay? And you should think about all 4 of them, and as we'll see, I'm going to talk mostly about the bottom one, and I'll explain why in the next slide, right? But I'll say what these are, okay? So correlation of activities over time, right? If I see that something is happening now, and then you come back to that location, or your pan moves to a particular location, and so a week from now, can I tell that it's the same guy? Okay, so that's what the first one is. Second category is location tracking. Is, oh, I saw that you were sitting in the IETF network, and then tomorrow I have some way to tell that, oh, now that entity is over at the coffee shop, and then later that afternoon I can tell, oh, you're in that particular hotel, right? That starts to be able to track individual people as they move around between locations. The same person works here, shops here, lives there, so on. The third category is device-specific vulnerability, okay, which is if I can find you and then I can fingerprint you somehow, and then I know how to attack you because I know that you're one of these types of devices, and I know what the zero-day vulnerabilities are. I just discovered one, so I know what to attack. I know what type of exploit to use against you if I can tell what kind of device you are or what kind of manufacturer or OS or whatever. And the fourth one is, of course, just address scanning, okay, which is I somehow know a prefix, okay, either because it's here on the network or because I'm a server and somebody is connected to me from that one, so I've got the address in a log someplace, or I saw a packet go by on the internet, okay? And so I've got this prefix. Maybe that prefix is old, but I can address scan that prefix, okay? What I'm trying to do is I'm trying to find a device. So next slide is, Okay. So I'm going to talk for the rest of this mostly about address scanning, and I consider that one to be an enabler of all the other ones. Okay. Now, of course, as I mentioned, you can find addresses without address scanning. Say, if I'm running a server, I look at a log, I see a packet flying by in the middle of the network, right? But address scanning a lot can be done by anybody who's not even on path, right? So it's actually, it widens the surface area, right? If you're on link, yeah, you can see some stuff. If you're on path, yeah, you can see some stuff. If you're neither of those, you got to do an address scan, okay? So that's kind of anybody on the internet can attack you if you can do an address scan, okay? So that's why I'm going to concentrate mostly on this one. And that also means that every document should say how it mitigates address scans. You'll see, and I'm going to talk about how you might say that, different ways to address that. Okay, so sorry the font size is a little bit small here, but let's see. If the link can be connected to the internet, if you can send a packet out, then you might be susceptible to address scans unless you say that how you're not, okay? If you're not connected to the internet or to any other untrusted network, then maybe you don't actually need an address other than link local addresses. And all the documents have addresses besides link local addresses, so this is all relevant to you. Okay, so to mitigate an address scan, I'm going to keep talking about this one a number of times, is it depends on the lifetime of that link, right? If the link is ephemeral and it comes up and it goes away after 2 seconds because it waits for 1 round trip time and you're done, maybe it's the length of a single NFC tap or something, then address scans can be largely mitigated by having the lifetime of the link be extremely short, okay? And that's okay, okay? And so it really says, what is the lifetime or the expected lifetime of the link and of the addresses on that link? How long are they there? Are they only a couple seconds? Can they be indefinite, okay? And so for cases that it might be indefinite, then a good rule of thumb is you probably need about 46 bits of entropy or more, okay? That's if it can be indefinitely there. If it's ephemeral, you need less, okay? So the general rule is how long does it take you to address scan comes from the ICP rate limiting that's in most routers, which is 2 per second, okay? So in order to address scan, I send a packet, and I really rely on, do I get something back? And in some cases, if it's not there, I get back an ICMP unreachable. And I can use that to infer whether something is there or not. Do I get a SYNAC? Do I get a ping? Usually you say, if I don't get an ICMP error, then there's probably something there, and I can start doing port scans or some other type of exploit, okay? Which means that you're naturally rate limited at 2 per second in most routers and systems across the internet, okay? And so that's where a number of the math comes from, is that inherent limit. So it has nothing to do with CPU per se. It's about how fast can you actually discover and do an address scan based on rate limits of packets. Okay. So the goal is to minimize the chance of finding addresses on that particular link before the devices go away. Okay. And so if you want that to be, say, much less than 50% chance of finding any device on the link, then it depends on how many bits of entropy you have, how many devices are on the link, and how long is the link and those addresses around, okay? And the math comes out as follows, that if you have the number of devices is 2 to the something, the number of scan tries is 2 to the something, you add those together, you add 1, and that's how many bits of entropy that you need. So for example, let's say that you have 10 bits of entropy, meaning you have an address space of, say, 10 bits that you can use, okay, that you're picking addresses out of, and then you're padding the rest or whatever. So if you have 10 bits of entropy, and in this example, let's say you have 16 devices that are on that particular link, so that's 2 to the 4, and that means that you can scan it in 2 to the 5 seconds. Why is that? Well, 10 bits of entropy means there's 1,024 addresses. There's 16 devices, so that means on the average, there's a device on there. About every 64 addresses, one of those is used. Okay, I can do 2 per second. So I can do a scan of about 16 seconds, 32 of those, and then the 50% chance among the 32, I'll hit one of the ones because there's every 64. Okay, roughly take it. That's approximations and stuff there, but it's kind of intuitive when you look at that. It says, okay, I can scan 32 addresses in a particular period of time, and with 10 bits of entropy, yeah, if there's 16 devices on there, 50% chance, I'm halfway to 64, I'll find one. Okay, so think about this, and I'll get to a table in just a second here. And of course, you want to do this without losing the efficiency. Yeah. Okay, so in all the RFCs and working group documents and stuff, generally speaking, there's 2 categories of ways that addresses are constructed. Okay, and in some cases, both are allowed. Right, one is allowing a full random 48 bits or 64 bits, right? In other words, it doesn't constrain that. You can pick any 48-bit EUI you want or any 64 that you want, okay? And another category of stuff is you have something that's a layer 2 address or a short address and that you're using that to construct, okay? And some technologies allow both, right? Okay. So if you can fully randomize the EUI48 or EUI64, well, EUI48s, when you randomize them, you get 46 bits of entropy and you're good pretty much no matter where you are. Okay, so if you can use you're completely unconstrained on which EUI48s or EUI64s you can say that, and that's a sufficient way to mitigate address scans. And of course, you can fully allot IPv6 addresses and blah blah blah. Now, out of the privacy threats that I mentioned in the previous slide, that's sufficient to mitigate all the ones except for a correlation over time, which you still need to cover. Okay, which is how often can I change that, as opposed to how long does the link last. Okay, so you got to cover that particular issue. So for example, if you say, well, you could change it every time you connect to the network. Okay, that would be an example. Under the assumptions are, that you'll connect to the network every so often, or the length of time that you're on a network is not days or something like that. Then some sentence to that effect is sufficient. Of course, this is only true for layer 2 technologies that allow you to use arbitrary EUI64s or EUI48s, as opposed to constructing them from a short address, which I'll cover next. So when I looked at the RFCs and working group drafts, this is the table that I constructed, and sorry if there's any errors here, but this is what I could gather. And so this is the list of stuff that's either an RFC or a working group document. And on the right side is what I could get out of the stateless adder sections in the different RFCs and documents. And so let me just run through these. Some of these say that you can use an EUI64 or EUI48, which is great. Other ones use a short address, which might be lower than 46 bits, and so there's more to say, meaning you either have to argue that the link lifetime is very small and say that the math that I showed you, oh yeah, well the lifetime is this much, therefore 40 bits or 16 bits is sufficient because it only lasts for a couple seconds and the math works out. Okay, great. So that's the category. Hopefully I didn't make any mistakes there, and these are drafts they could rev at any time. I noticed one was reposted today. If you allow 2 categories of stuff, such as 48, that should be 49, 44, that's a typo, right? That one, and DEC dually, if you have 2 mechanisms or 6 back, that means you got to answer it twice, right? You can't just say, oh, well, it's mitigated by this one. You say, well, what if you're using the other one? Is there you shouldn't do that one, and so on. So I think the DEC dually actually has a should and so on about that as one example, so. All right, so let's talk about, all right, so now you're in one of these categories of stuff that only has these short addresses. So you don't have 46 bits, you got to say more, right? So we could talk about, NFC that we were just talking about, or we could talk about the RFC 7428, which have very short numbers, or even 6LO back if using the 8-bit address run. Okay, what do you have to say? Okay, so if all you're doing is you're padding with a well-known prefix, well, that makes it really easy to scan. So if it's a long-lived link, and it's just padded with a well-known prefix like zeros or 0FFFE or whatever, then that's really easy to scan. Now, if you're in that category where you could have a non-ephemeral link, meaning it lasts for more than a few seconds or whatever based on the bits math that I showed you, then another thing that you could do, given that you're not an RFC yet, or out of the ones that aren't an RFC yet, if this is a problem, you could do something like, rather than padding it with a well-known prefix, use some other construction that still uses information that everybody in the link knows. And the example that I gave here is to say, well, you have a layer 2 network key or a PAN ID in the Bluetooth case or whatever. You have your short address thing, maybe something like the ABRO version, basically whatever information that everybody in the link would already know. And instead of simply padding it, you use a hash of that algorithm so it spreads out across the entire 64 bits. So if you use a simple hash, that's also sufficient mitigation and will last you for a long period of time for having the link up more than a few seconds. Okay, so this would be, if you're going to design one of these that might last for more than a couple seconds, consider not just doing a simple pad, consider doing a hash based on information that everyone in the link knows. Okay, because that still allows you to do completely stateless compression, get rid of the addresses, because on the decompression side, you have all the data you need to decompress. Does that make sense? Okay. All right, so here's the specific recommendations in one slide as to what are the things that you should put into your security consideration section. Okay, so the first one is you should say how the address scan is mitigated. That might be by saying the lifetime of the link is very short, it's only a couple seconds. Okay, That's one way of saying that. Another way of saying that is to say, well, we allow a large number of bits of entropy, such as arbitrary UI64s, or show the math to say, well, it's kind of sum of each, and it kind of evens out, right? 16 bits in a minute or something like that, and the math works out, right? Secondly, actually, this one goes along with the same one, is to show that it includes sufficient bits of entropy based on the maximum link lifetime. So that's really the same bullet. Corollary, don't just pad something with zeros or a well-known suffix unless you're arguing that the link lifetime is very short. Okay, so it's common practice to do that right now, and what's missing in the documents is any argument that says, and the link lifetime is very short, and therefore this is okay. Now that might be the case, but that's missing from security consideration sections documents, the ones that I looked at. Okay, so if you're one of the authors, something else to put into your document. And hopefully you're okay, but if not, you should think about changing to the example of the other algorithm or something equivalent, or finding another way to mitigate it if there's another way. Lastly, make sure that the IPv6 address can change over long periods of time. The one I'm using today and the one I'm using next week, that they can be different. However that happens, describe it. Say, yep, the short address is negotiated on the fly, or gee, it's burned into the thing, but the thing isn't actually used for address construction, or whatever it is. And so this mitigates the correlation over time, which is the only one that the address scans doesn't inherently do. You got to cover the lifetime of the address issue too. Do I change the short address? Do I change the EUI? Do I just change the IPv6 address but they stay constant, or whatever it is? And then lastly, if the device can roam between networks, right? So sometimes it's over here and sometimes it's over there because I carry it with me and I'm getting different prefixes I'm roaming around or what have you. And there's more than a few bits of entropy that exist. Then you also have to make sure it can vary by network. Okay, so this one isn't necessarily obvious in the previous one. So if I only have like 3 bits or something like that, then it's hard to identify that 3 bits is Dave because everybody's going to be using a different variation of the same 3 bits, right? The set of it doesn't uniquely identify me. Of course, if I have 15 different devices on me, then maybe the combination of them might. But if more than a few bits, if I actually have 64 bits of entropy, let's say, that's a fairly unique identifier. Okay. And so I don't want to keep that same 64 bits if I move to a completely different location because I can be tracked by that 64 bits. Does that make sense? So the more bits you have, the more important it is to change it. The fewer bits you have, the less important it is to change it when you move networks. All right. Okay. So that is my last slide. That's the sort of stuff that we expect to be in security consideration sections to mitigate privacy.
Brian Haberman, I am by no means going to claim to be the source of this question, but one of the comments that I've heard over and over again from different people is, would these recommendations change talking about different types of devices between, say, a cell phone, a sensor device, and a server in a data center?
For these, what's important is how long is that device on the network at a time? Okay, is it always on, like in some cases, if you're talking about your cellular network, then in some cases you might think your cell phone is always on or always reachable, right? If it's a sensor, then maybe it's permanent. In some other cases, it may be ephemeral. And so it goes back to the timeliness issue here, which is it's more important to have, to mitigate address scans the longer you are on a network. So if I have a sensor that's built into the wall here like a thermostat, it's far more important to mitigate address scans for that than for something that goes in and out and is only on the network for a minute at a time.
So I think Brian asked that question. I would just put that a little differently. So I guess that assumption is that privacy is a requirement, right? And right. Where privacy is a requirement, then this recommendation should follow.
Right. I think right now we should assume that by default privacy is a requirement everywhere, and you just have to explain how you mitigate that. And there might be different ways to mitigate it in different cases.
Right.
The mitigation might be physical, it might be
Correct.
Mathical, cryptographical, it might be something else.
Yeah. So yeah, I agree with that one. But what I think some of the use cases, what I have seen that yes, it is for longer term. Even not only that, days, it's a years after years. And for example, for them, location may be fixed. Even maybe have a civic address or something like that. Some of the applications. So
that's true. Yes, if you say that the class of devices that this is designed for are ones that don't roam, then you've mitigated location tracking because you don't.
Correct. So only thing is that what I'm trying to get at is that in certain use cases, making privacy is a requirement, maybe a little bit, difficult to convince the user community that's okay, because whatever mechanisms we do, for example, that location tracking and all these things, cannot be mitigated because that's the way the devices are placed, and there are a lot of other ways other than address scanning that device can be found, right?
Mm-hmm.
So for that kind of cases, right, just providing a privacy, would be extremely difficult. And but I think I agree for the general recommendations for any document. I think if these pieces are there, then an user can decide that okay, whether this is required or not.
Right. Yeah, I'm not trying to argue for any particular mitigation. What I'm trying to argue is that the security consideration of a document should say what the answer is for each of these.
Yeah, I agree with Subir, but at the same time, I thank you for the guidance. And I think right now it makes it clear how to write those sections in our document. And also the flexibility for when and how often we can change the addresses in different use cases. So those are all good. Just one clarification question. So if I have a link layer which is secure, I know, do you still recommend that we should use the privacy consideration of changing addresses?
Yes, because what you're trying to protect against is not anybody that's on the link. When you say secure, it depends on what you mean by secure.
I mean, attacker.
If it can be
anybody.
seen from the internet, then privacy is an issue.
So it's mostly for location tracking, or I think that's probably the most.
So a specific threat is if you remember in the Dallas plenary, Hannes and I gave talks about IoT, and one of the main points of our presentation was that in a lot of these IoT class devices, they're insecure in the sense of they're deployed for a long period of time and the firmware isn't revved, and so the things that have been out there for 5 years are hackable and people leave them for long periods of time. That's one use case, right? And so once you address scan stuff, the device-specific vulnerability exploitation gets really bad, okay? And in particular, because it may be interacting with the real world in some use cases, right? Then that's a very dangerous thing. Is if I can address scan something, I can then attack that thing. I may now have something, I may now be able to compromise something on your secure link, and now it's inside your little boundary, right? And so, it's harder because these IoT class devices may be constrained in a way that they don't have enough power or smarts or ways to rev them as fast in order to keep all the stuff up to date with all the basics, all the security stuff that will be relevant 5 years from now. Okay, and so address scans are even important in such an environment because it's the best way that you have to protect against them being compromised, because there's really no other way.
Yonggun, okay, thank you for your good document. So for the NFC document, for security consideration, we follow your recommendation. I have one question regarding address scan. Okay, it's good. So I agree. But if we think about some specific link layer technology, for example, NFC, is ideally it covers 1 meter, but actually it covers 10 or 20 centimeters. So I don't believe that the address scan can happen when you use the NFC technology. If some other guy overhearing the operation, we can know and we can prevent it. So it must be case by case. Some link layer technology must follow, but in some link layer technology, it may be not needed. So.
Right. I think there's enough heterogeneity across the different use cases within this working group. I don't think there's any one-size-fits-all thing, right? So that's why my goal is to say, here are the things that you need to cover. Exactly how you cover them, I can imagine would be very different for every single document. Okay. So for the NFC case, for you guys, if it's a small number of bits, maybe for you guys, and I don't know if this is the case because I'm not the NFC expert, but the use cases I'm familiar with, it's like tap, and so the lifetime of the NFC connection is like number of seconds or less, right? And so that may be a sufficient mitigation. So the way that you would cover it would be very different from how, say, Bluetooth or something would cover it, which could last for long periods of time.
Okay, thank you.
Robert Craigie. So just clarification here. This is definitely about addresses which are used in the wider internet. Because we have this kind of...
addresses that are used to communicate to the internet.
Yeah, so...
Or well, actually, if I go back to my slide, I had an or that was in there. It's the internet or any untrusted network. Because you may be connecting to some local hotspot or local public environment which may not be connected to the internet. If it's untrusted, somebody could address scan you, then yeah.
Because in some of these route over mesh networks, we have lots of addresses, lots of IP addresses, and some of those are really only used within that, what we call this realm local scope.
Location tracking can still happen even if you're not connected to the internet. So let's say I have a constrained environment, but something can roam in and out.
Yeah.
Okay? And so if that's a public enough network, and now I've observed you come into that network, and I can see your address. I'm not using address scans, but I can do location tracking, as I can tell, oh gosh, this guy comes and buys coffee every day, and because I can see he's got some stable identifier, I can also tell that he's the same guy that works at that company, right? But at least I can track you over time if you keep coming back to that network.
Okay.
Yeah, so those are some of the
that's a different sort of
considerations.
address to the ones I'm thinking of.
Yep. So even in those, address scans maybe not so much, but tracking over time can still be an issue.
James Woodyard Nest. And following up to Robert's question, it seems to me that when you talk about the internet here, that's a capital I, and that sort of suggests to me that it's especially dangerous for links that connect to devices on the public internet. But I wonder if it might be a little bit less, and if so, how much less dangerous if it connects to sort of a private overlay network that has some limited reachability domain, but not local, but still not the public internet. And how do you talk about that in a document that's a sub-IPv6? Because you might have links that say, well, here's what you have to do for global scope addresses that are going to be usable on the public internet because we really care about mitigating address scanning and privacy and location tracking there. But on these virtual overlay networks where we use unique local addresses, that this allows us the opportunity to optimize our 6LO compression, and we can use addresses that can be compressed better. And we're not so much worried about the location tracking and the privacy considerations there because these addresses are unique local and they're not publicly routable. How do you say that?
Let me just, I'm going to cut the line right now, and I would please be brief in your...
I'm going to let Bob speak first because it looked like he was going to respond to you, and then if he doesn't answer everything that I was going to say, then I'll speak up.
Bob Moskowitz, I have some real concerns about saying, well, this device is only being used locally. Therefore, I don't care about its address so much because there may be some service or other thing on your local network which is keeping in some log or something that address, and maybe something about the characteristics of that device, and then that box, which does have a public address, gets compromised, and now the addresses of everything else inside your local network are known, and now that then maybe more richer attack points become known for the next step. Even if it's a unique link local, it can be, oh, I can now step from where I'm here to there. So if there's any permanency for this device, we need to start looking at how we roll our addresses over time to limit the trackability. Been thinking a lot about this in the past couple months, and really got to think. We need to think really very hard on how we break this historical chain of address tracking.
Yep. So if I want you to remember one thing, it's if you show how you pad an address, and that's all you say, you should expect to discuss.
Quick question. This seems to have useful information, useful enough that people are already using it, actually.
Yeah.
I'm wondering about adoption, path forward, is like an informational, for example, or...
Yeah. So right now, the document that is referenced on the title actually covers sort of two disjoint things.
Right.
And I would want to split those.
Yes.
And so this time I'm only presenting the part of it that's like what you put into a document.
That might be something.
And
good
so
to
that's the one that I would
progress.
say, yes, but let me do the split before doing that. But then I would say, yes, I would ask that. But that's why I didn't ask it this time, is because I haven't read it since last IETF, and that's what I would plan to do.
Okay. In the meantime, please don't wait for it to be an RFC. Please keep using it.
Yeah, so right now the slides are actually a slightly better reference than the document, because the document has a bunch of other stuff in it too, and you got to wait through it. So.
Thank you.
Okay. So, okay, my name is Subhiddas. I will just present on behalf of Joshi. I think he is could not attend the meeting, but he is listening to the audio and the Jabber. So if you ask any hard question, I will pass to him, instead of answering me. So let me give you some of the backgrounds, because this draft actually has a lot of dependencies also in other drafts, which you will not get the separate presentations, but I will also request some other folks here to explain that what is happening. The first draft actually for the heap decks, which is actually Bob's draft, and good news is that Bob, with his co-author, updated that document and even submitted another version this week here, which is a very lightweight, key exchange protocol with a static ECDH. And this document is also actually submitted here, and that is actually required to progress in order to progress this draft. Then the MLE draft, which is Mesh Link Establishment Protocol, which was actually has a little bit long history. That was an earlier draft for the internet area, and Richard is the author for that, and it went to all the way to the almost in that ISG review, and there are a lot of comments, but then those comments were not being addressed, and the draft was not updated. Then it expired, and it was staying for a long time. But there are external actually bodies who are using that draft, and you will see that example here. That's what but with the help of Robert and also myself, we discussed with Richard, and Richard updated that draft before this IETF and submitted in the 6LO. So that is actually the main draft, which is also required to be progressed in order to do that. And I will actually request Robert to say something about that, because Robert actually shepherded on that particular MLE draft. Robert, would you mind just say a few words about that?
Yeah, sure. I think you've covered most of it. As you say, it's been resubmitted now, so I think there's a couple of extensions which we want to put in, one on the length, but basically the people who are using it, like Thread and Zigbee and people like that, we're all involved in this process as well, so we can make sure that there's no conflicts or anything. So the aim is to take this document, hopefully get it as a working group draft here, and then put the changes in needed just as a base document, and then the extensions will be in separate drafts like the one you're presenting now.
Okay, thanks, Robert. And I think that's one of the other things, just to let the chairs know, that we have also identified some reviewers for this document, and we'll actually help to review that document early on. But we definitely request that working group, that's a request for the adoption for the working group, that document. One of the important part is that what we, from an external organization point of view, like Zigbee Alliance and also that thread, what Robert mentioned, that the status of the draft, I think not that critical, right? It's getting an RFC, referencing that, and a normative reference is important. But whatever that working group decision will be, and making that progress and getting good review and incorporating the comments would be important for the MLE.
I can wait for your presentation. I'm here to relay something from the Jabber room.
Okay. So then I think that's okay. So then this particular presentation, which I'll be covering very briefly, is that it's a combination of heap decks and MLE. So it's trying to actually optimize these two operations with a less number of messages. It's just an optimization, because heap decks requires 4-way handshakes, and then MLE required 3 messages, which is equivalent to 7 messages, and which is like 5-way 2.5 round trips. Instead, this draft is proposing instead of 7-way, which is 3.5 round trips. And this was presented in the last IETF 6LO meeting, and there is some small extension for the draft. Okay. So then what are the changes? Actually, that 3 minor changes happened, and these were the results of some of the discussions, and that in the other organization, what is happening. That first thing is change is that the key derivation algorithm for that, it was currently that it was separate for group key and the MLE key. Now both are derived from a group master key. And then there are 2 different rules are added on the frame counters. The first thing is that frame counter, there is an implicit assumption here that this is assuming that 15.4 2011 specification, because the way frame counters are used there is a little bit different with the new version which will be coming in the 2015. But if the 2015 document is used, that rule is not required for the frame counter. And then the third one is that another, actually this is a kind of a key switch. Basically, that's when the key update happens to the MLE. That then if the frame counters are the way frame counters are actually used, then that the key update message somehow, because MLE transports over UDP, is lost, then the device will not have any way to actually go to the previous state. So there has to be an explicit, key switch message that would require to update the key. So for that particular reason, that there is a rule is added in the MAC behavior. Yes.
Is your presentation finished? Are you ready for questions?
So I think this is the change, and then now I can move to the next slide. But basically, this is just saying that, okay, what are the external organization, what is required for this document, and we will appreciate that working group considerations for the working group document. Yes, and that this is the last slide.
Okay. So the question came in from the Jabber room from, I think, Michael Richardson.
Yeah.
The question is, Plugfest at IETF 94 for this question mark?
Actually, yeah. So we have not decided yet, but as you can imagine that since external organizations are actually discussing that, there will be specific interop events for that organization itself. But we can definitely discuss that in a future IETF event, if another Plugfest can be arranged. But at this point, there is no such intention. But if the people are interested, we can definitely talk about that.
Doesn't look like there's any follow-up on the Jabber room. So
okay,
I'm going to assume that's good enough.
I think that's a good question. But one thing I can tell you from a ZigBee Alliance perspective, of course, that Alliance requirement is that before the specification is published, there has to go to multiple interop events, and it has to pass that, the specific peaks requirement and other things. So, and that's the requirement, as you know, that any of these external industry organizations make sure that it really works and it passes that requirements, all these things. Of course, that since a lot of that, not only these drafts, there are a lot of IETF, RFCs are being used. So whenever that must and should are there, that has to pass through that requirements.
I have a couple of things to add to this. Be working on getting a security view of the HIPDEX. There are 2 unique. HIPDEX is a subset of HIP v2. Much of the text is almost a straight copy from RFC 7401. But one of the key features is, since it assumes there is no cryptographic hash, it uses a CMAC key derivation function instead of an HMAC key derivation function. And that, though, is defined in the literature. This is our very first IETF document that I know of that specifies a CKDF. So that should get some heavy look at, but I did have some heavy lifting on the initial design of it. So I just wanted to mention that. It is literally the least number of cryptographic primitives that we can have to do something. I have working with a couple vendors on 8-bit processors where they are successfully doing this sort of an operation. So it is truly workable in highly constrained devices, very low memory devices, lower than is typically set as the targets around here. So I'd like to say that. As a separate IEEE comment, I've just sent to the IEEE SA the documents for 802.15.9 to go into sponsor ballot, the 30-day sponsor ballot. So once Lisa gets everything up there, that document will be purchasable from the IEEE store. That is their current process. So the 15.9 document will be purchasable as a sponsored ballot document in short term, whenever she gets it, everything's ready and opened up.
Yeah, thanks for pointing out. I would like to add one thing here is that, don't be scared about that you have to purchase. There is also another process. I think that there is also an IEEE and IETF coordination, committee there, and there is a representative. So if someone is really participating IETF and interested, and I believe that Brian can correct me, that person can actually go through that channel to get the draft. There is a way that draft can be shared.
Dan is the
IETF,
contact for
yes,
that.
exactly. So I think that if there is a requirement, that draft can be actually obtained free from that. And Pat, Taylor, who is that 802 vice chair, is a representative from the IEEE side. So we will make sure that if you require that document, you get the document.
Okay.
So,
Okay. So thank you, Subir. For the interest of time, we have to now.
So I
cut
think
the
only thing I'd
discussion,
like to
and
mention
we are
that
running about 15 minutes
to
late.
request the chairs that what would be the process to actually getting that working group acceptance for this and other documents.
Yeah. So let us ask the working group. How many people have actually read this document? Okay. I see quite a few. Do you have any objection to adopt this document as a working group document? And I think they are looking for an experimental RFC at this point. Right. I guess I didn't see any hand for objection, so I assume in this group they are okay in adoption, and we will send an email to the mailing list.
Okay, thank you very much.
Thanks. Randy is not here. So.
Okay. Is it updated, the slides? I hope so. Hi, I'm Inés Robles. I'm going to present as well in behalf of Felipe and Roberto that are not here. We think that we can apply 6LO-PAN techniques to this new IEEE amended 11AH. Okay, IEEE is amended, operating in the industrial, scientific, medical radio band of 900 megahertz, which has a OFDM multiplexing, modulation, orthogonal frequency division multiplexing, with a symbol, a long symbol. The symbol takes a length of 40 microseconds. That means the air time transmission has long period, so take a long time to transmit packets. So we think that this is a reason as well to push to apply the reduction of IPv6 header overhead. Yes. Next one, please. This standard as well has some features. These amended, like they try to reduce the MAC overhead with some techniques. For example, they define this protocol version 1 frame format, which has Okay, the frame control, the address, destination source, frame body, the frame check sequence. And we have here 6226. That means that it can use the full MAC address of 6 bytes or 2 bytes of association ID. The combination, the possible combination are 6 to 6 when this standard is Wi-Fi, so it has station and access points. So when the station and access point doesn't know each other, they use the full MAC address 6 to 6. And after when they do the association process, they set some associations, so they can use the short ID, as the 2 bytes. So the combination could be 6 to 6, 2 6, 2 6 2, but no 2 2. As well, they have this amended defined short beacons, like 100 bytes, and as well they define this MAC header compression. Yeah, we are not going to get into detail of that, but it's a stateful compression. They avoid fields when they have an association in a session. They set a session and they just, they know each other, they can avoid to put the fields. Thank you. Okay, the topology of this amended is a star topology. They don't have a defined mesh topology. And of a station, we have 2 types of stations. A sensor station that has power constraint requirements. So as well as if we apply here 6-loop technique, we reduce overhead. So we think we are going to save energy because they are battery operated devices. Access point and non-sensor stations are power line. They are not constraint devices. And recently, IEEE people told us that, the flow of information is unidirectional, and we can have station access point station. And recently the IEEE people told us that we can have a station to extension communications using 11set, that they use TDLS, like a tunneling direct setup. Link setup, but we are still looking into it because it's recent, so we have to look deeply on that. And as well, they told us that maybe they can have some communication between access point, because in the draft say that the access point cannot communicate with the 11AH, but they say that they can communicate with this relay device, but this layer 2 device is transparent to layer 3. So we are still looking as well into it and working with them, try to clarify some definitions.
So can I ask a quick question? Yeah. So I see here we have a start topology, right?
Yeah, start topology.
So can the AP to AP communication can happen in a mesh, or how does it work?
The AH doesn't define mesh, but they say that you can transmit information to other access point by a relay. But we have to look into that deeply because we don't know yet. But the standard doesn't define mesh, just the start. Start topology.
Okay.
So for this reason, we think that we can, if we use the reduction overhead of IPv6, we can save energy on the battery operated devices, and as well we are going to have a better use of the basic BSS, basic sentence set, sequence set. Next, please. Okay, the topology that we think that we are going to have is like we are not going to have the 6LO border router because we don't have mesh topology. Router. We are going to have only 6LO nodes and 6LO border routers. For that, we are going to skip the 6LR, the router. Next. Okay. Some slides are missing here. The slide that I sent by email. The new version of the slide that I sent by email. Okay. Well, By email,
Did you send both to both of us?
Yes.
Okay.
Today. Was today? Okay. Just we have a graph. We did some graph with MATLAB.
Are looking. I don't see anything.
Oh.
I don't see it. Maybe you can go on without it.
Oh, okay. Just we have like a graph where we did a calculation in MATLAB. So the graph was like that, the results. So we have the bytes transmitted here at the gain using the 2 megahertz bandwidth. That is the full bandwidth of this amended. And we use the MCS 0, that is a modulation and codification scheme 0, with bit rate of 700 kilobits per second. So in the calculation that we did, we have, if we transmit 100 bytes, we will have 30% of gain. But as long as we transmit more bytes, the gain is reduced. So, but we think that it's going to be like sensors. The transmission of the byte is going to be short. So we are going to have a good gain on that. That was the graph, like that.
Sorry. Yeah.
No, it's okay. Sorry. Yeah, sorry. And other graph that we have as well is Wi-Fi standard. So we are going to have the LLC layer, 802 LLC layer. And for that, we are going to need to define this IEEE identifier, like has for IPv4 and IPv6. If we apply a 6LO PAN, we will need this IEEE identifier to be defined as well. So, and now how to apply this for 6LO PAN. So we are still addressing this part. We are still working on that. For example, for the RFC 67575, that's network discovery, the things the things defined for multi-mesh, for mesh, it's not going to multi-hop or that it's not going to be applied to here, just all related with the star topology. Yeah, we are still working on that. Will be good if we have your feedback on the mailing list. Yeah.
Can you go back one slide on the topology, please? That's Pascal Thubert.
Yeah.
Yes. So what I see here is a single AP with several stations around it. And so that's the BSS. And I was wondering if AH has the concept of an ESS as well. Do you have the concept of having an Ethernet connecting several APs?
It's wireless.
ESS? Like this is a BSS, right?
Yes, BSS.
So do you have ESS in AH?
I don't know, but we can, if you write down your question by email, we can research and answer by email. I don't.
Maybe
I
you
don't
can
think so.
ask that question on the mailing list, so she will find it out.
Please, the mailing list.
Just wanted to double check a few things. This seems like to be a completely different link layer from regular .11, but I wanted to verify that. I mean, there is no way these two get confused. Is that correct? It's
No.
different PHY, different MAC, different.
Yeah, I mean, yes, it's in progress. I mean, the standard is in progress. It's a new amended, and I think they are going to release the final version December last year, next year.
But my question is more between in any given network. Let's say here there's Wi-Fi, regular 802.11. And let's say I have a 802.11 AH devices. Will they get confused at all?
No, I don't think so.
Complete different link layer, 5 MAC, right?
Because the technique of transmission is different of the letters.
Okay.
So this is 900 megahertz. So I think.
And the frame was different as well.
Yeah, you have protocol version 0 that has some fields similar to the other ones, but you can set this field at 0. But we define the short protocol version 1.
Okay.
They define as well protocol version 0 and protocol version 1.
So my request is because if if there's a standard 6LoWPAN here and you want to talk and you end up talking to like a .11, you won't communicate. So it would be great to have in the draft why that will not happen. Why this is such a different link layer. Those two guys will not have an interoperability problem. They wouldn't even try to talk.
Yeah.
So it'd be great to clarify that.
Okay. Thank you.
The other question I had is, did you say you were in touch with IEEE already, or?
Yeah, they review our draft and send some comments.
Oh, they did. Okay, great. I also spoke, FYI, I spoke with Dorothy Stanley here at the IETF. She's
standing behind you.
Oh, there you are. So please say
I'm Dorothy Stanley.
Hi.
So my affiliation is HP at Aruba Networks, and I serve as the liaison from .11 to the IETF. And when I saw your draft, so I sent that to the .11 reflector, and thus you received comments back on the document. So to quickly answer Gabrielle's question, you're exactly right. This is it's a separate amendment. The protocol version is changed. So on the link layer, the two non-11H systems will not get confused with 11H systems. The question about once you're in the network and I have a 6LoWPAN 11AH network, now I want to interface that with a .11 network. That's a different interface. So there must be some interface from going presumably through your border router back to non-6LoWPAN IPv6 or IPv4 networks.
Yeah, I think the LLC defined that. When you go to the LLC, decide 6LoWPAN, IPv4, IPv6, and go to the next layer, right? I mean, we will need to define some IEEE identifier in the LLC.
Identifier to do that. So I look forward to working with you on this.
Great.
I think it's an exciting area, and I'm glad to see your work here. I was also asked the question separately by someone who said, well, it's great to put 6LoWPAN over AH, but what about putting 6LoWPAN over just .11, non-11 AH systems? So I'd like to explore that as well.
Oh, okay. Yeah, we can. Thank you very much.
I had one more question. This is I believe the first time AH is presented in IETF.
I think so.
I think so.
I didn't.
Could you just say 2 or 3 words about what it's used for? What is the expected application?
Well, we think that the RFC that was defined for common use cases apply to that. And the standard working group, they define some use cases, smart meters, but to work on the standard. But we think that it's the RFC 6405 from use cases, from constrained devices, apply to that as well. I mean, if you have a station and access point, you can have any application. I mean, we think that apply. Like, we don't have implementation yet. It's like hard to we can guess, but we think that we can apply this RFC in these cases.
So I guess you can update your document with the applicability section.
Mm-hmm. Yeah,
where you can explain the possible use cases. That will help.
It's there. I say in the first sentence that we can apply this RFC in the use case section.
Okay, so it looks like an interesting work. So keep updating your draft.
Yeah, we will.
Thank you.
Okay, thank you very much.
So who is next? Reza? Okay. I'm sorry, I'm coming.
Back. So this is about compressing the IPsec for 6LoWPAN networks. Status of this draft, this was first submitted to the IETF Smart Object Workshop in IETF 83, and then later it was submitted to 6LoWPAN, but that 6LoWPAN group was about to close, then moved to 6LO, and it was part of the 6LO buff. We couldn't get a chance actually to attend IETF and present, and this is our first time to present this draft in this working group. So if you want to secure Internet of Things, we could do it at different layers, and we have different advantages. So if you have a security at the link layer, then we can protect everything which is above. So this is a kind of security solution we need to protect against attacks in the wireless medium. It has two advantages, that if you have a multi-hop network, we can easily detect packets modification at the next hop. And if we don't have this link layer security and someone modifies at the first hop, the packet travels all the way to the destination, and there it is identified as a fake packet. So it could be used to deplete resources. We could have a security at the IP layer, which is between the drawback at the link layer is that it's just between two hops. So it's not end-to-end security in an IoT from between a host on the conventional internet and a device on the 6LoWPAN network. So we could have a security at the IP layer, and this is between two hosts. And the advantage here is we can, if we have an IP sec, for example, we can run TCP, UDP, or any other protocol, the transport layer protocol, and it can protect the IP headers as well. So if you have an AH, then one of the most famous identified by Arbor Networks, who actually worked on who can see significant part of the internet. They say if there's one attack against Internet of Things, it would be IP spoofing. And this IPsec can help us to actually mitigate this attack. And then, yes, of course, we can move one step above, and then we could have a security at the transport layer. It will be between two applications. And if we even want security between two data segments, we can go one step above, and we could have a security at the object level. That we have drafts on it, object security. So this presentation is about security at the IP layer using IPsec. But a few words about IPsec. IPsec is an end-to-end security at the network layer. It's usually part of the operating system, and we can protect the headers. That's important here. And we suggest IPsec transport mode for the Internet of Things. If you know IPsec for VPN and between two browser gateways, just forget about that. We are not talking about that IPsec. It's between two hosts using the IPsec transport mode. And basically there are two protocols, IPsec authentication header and encapsulated security protocol. I don't have time to go in details, but these are well-known protocols and one of the most used protocol on the conventional internet today. Compared with transport layer security, that's the browsers who do security on behalf of applications, but we don't have browsers in Internet of Things or in constrained devices actually. And AH and ESP, this is important because when I talk about the linkage between IPsec and 6LoWPAN network, we should note that the AH and ESP are IP extension headers.
Sahid, you have 5 more minutes. We have another presentation.
Okay.
So,
yes. So we have a IP datagram where we can use IPHC to compress this. This is already defined in the 6LoWPAN standard. And 6LoWPAN standard also defines how we can compress the other headers. For example, we have a generic format where variable length ID and then the compressed headers. And 6LoWPAN already defined this for extension headers and IP headers. And the proposal here is to use this for IPsec. So in this extension headers EID, there are 8 possible values. 6 are already defined in the 6LoWPAN standard. 2 values are reserved. If you look at RFC 2460, and if you look at the sequence or order of the headers, then the AH and authentication headers are IPsec extension headers. So we propose that these two AH and authentication headers are actually the obvious place for these reserved bits. So there are 2 proposals here. So we have 2 reserved bits here. We can use one for authentication header and one for the encapsulated security protocol. This is a clean model, first proposal, but we could even use just one of these reserved bits to define AH and ESP headers, and then based on the variable length ID field in the NHC field, we can identify whether it's the AH header or the ESP header. I don't have time to go in detail how we actually compress it. You can read the draft. But I have some numbers actually for you. How much we can compress. For example, we can compress, if you look at the fixed headers, without IPsec, we have 12 bytes. We can compress it down to 4 bytes. And then we have additional 12 bytes, but it really depends what is the size of your authentication data, or ICV, integrity check value. And if we use ESP for confidentiality only, we can compress from 10 to 4 bytes, and same goes for ESP if you want both confidentiality and integrity. These are some numbers. The most important message here is, if you look at these numbers, we did implement it in Contiguous operating system, which is an operating system for the Internet of Things, and we can see from these numbers that IPsec with pre-shared keys and pre-established security associations, they actually fit in class 0 devices. And the class 0 devices are 10 max up to 10K of RAM. And then if you look at the 40, this is within the class 0 devices range. We did also, and another important message here, we did implement it and then we run it for different settings. If you want to see full details of all these settings, you can read this full journal paper, but here there is a message here. If you have a link layer security, it's at each hop. So we have to do cryptographic processing at each hop. And if we compare this with IPsec, it's end-to-end. So we have an important result here. So for example, if we have multi-hop network and if we send 512 bytes of data, then we see that just after two hops, IPsec, which is considered as very heavy, is actually better than 802.15.4 actually. So that's what we found when we implement both IPsec and IEEE 802.15.4 networks. And you can see full details how we do this and how you can replicate this result in this journal. And we have so many other graphs for this. And here is the source code. You can download it, you can run it, you can verify it. And we see it a very clean approach at the IP layer using the IPsec. It's not very heavy. It's lightweight. You can run definitely in class 0 and class 1 devices. And if you have more luxury, you can run it, of course, on the internet side as well. That's all from my side.
Bob Moskowitz, I have 3 points to bring up. First of all, I like to see how your compression compares to that in robust header compression. Are you doing the same ESP compression that's in RHC, or are you doing a different one? That's the first thing I would like to see. The second thing is your cipher suites you're using. Since many of these devices have AES-CCM already in them, why are you using a different cipher suite than AES-CCM for ESP? That's the second question I have. The third and final point I want to make is that, which I've stated extensively over the past 10 years, is that security at different layers is because we have different risks and liability. Security at the network layer is addressing the risk and liability of that network owner. Security at the IP layer is addressing the risk and liability of the system. So saying that one is better than the other only applies when there's the same owners, because you're addressing different risks and liabilities at layer 2 versus layer 3. So yes, one may be better than others in certain cases, but it depends on who is the owners on that. So it's not really a good apples to apples comparison. But I do like to know about those other 2 points compared to RHC, and why not AES-CCM for ESP?
First, I like to answer the third question. I agree with you. My point was not that IPsec is better than link layer security and its transport layer security. My point is it is a should to implement in IPv6, and this is the overhead if you want an IPsec in the IoT domain. And yes, definitely, if you think that in your settings the link layer security is better, use it. If it's transport layer security, go for it, and object security, go for it. Yeah. But this is one solution for you. For example, it is already adapted in ISO standard for intelligent transportation.
We need to close the line right now because we have one more presentation in like less than 5 minutes.
But I'll be happy to answer then your question on the mailing list.
Thank
Please review.
Hi guys, I'll make this quick. Try to get back on schedule. A few weeks ago, I submitted a kind of a Kickstarter draft on configuring 6282 compression contacts over DHCP in a low band. This work came from, much like Sabir's presentation, it came from a requirement in the Zigbee world, Zigbee NAND specifically for very large networks to configure parameters besides the basic parameters that come over ND or Ripple or whatever you're going to use to configure your network. And so